Hello everyone, welcome to course study on solid mechanics. In today's lecture we are going to discuss experiment number 3 and the title of it is compressive strength of the brick. Okay, so first of all we will discuss what does the compressive strength means. It is a most important property of the brick because they are to be used in the load bearing wall. So all of you know that brick we can use for the construction of load bearing wall, for the construction of pillar or for the construction of arches. So when it is used for such a cases, it is subjected to compressive stresses. Okay, so it is very important to determine the compressive characteristic of the brick. So in today's practical, we are going to determine the compressive strength of the brick. Remember that the compressive strength of the brick, it depends upon the composition of the clay and the degree to which it burns. Okay, this figure shows the instrument which is to be used for the compression test of brick, and it is known as compression testing machine. This particular diagram, it is a diagram of compression testing machine and which is used for the testing of brick. Okay, or this particular diagram, it is also the compression testing machine. So first of all we will discuss the aim of today's practical. The aim is to determine the compressive strength of the burnt clay brick. Okay, we have to determine the compressive strength of the burnt clay brick. What is the purpose of today's practical? The purpose of this test is to give an idea about the quality and the class of the brick to be tested. So it gives the quality and the class of the brick for the compression testing. The references are IS 1077 1992 specification of common burnt clay brick. The same references we have used for the water absorption test also, or the efflorescence test also. Okay, the second reference is IS 3102 1965 classification of the brick. The third reference is IS 3495 part 2 1992. It gives the methods of test of burnt clay brick. And the last reference is IS 5454 1978 methods of sampling of burnt clay brick. Okay, so those are the references which we have followed for the compression test of the brick. The apparatus required is UTM. UTM means, the full form of UTM is Universal Testing Machine. The full form of UTM is Universal Testing Machine. Okay, next on metal tray, trowel we will require, the curing tank, weighing balance and the scale. Those are the apparatus which we will require to perform the compression test of the brick. Okay, the material required is 5 samples of the burnt clay brick, cement, sand and 2 plywood sheets of 3 mm thick, and it also requires the water. So those are the materials which we will require to perform the test. The theory is bricks are important building material used in the construction work since long. Okay, it is manufactured locally using the local material, or it is manufactured locally by using a local clay. They are mainly used in the construction of wall, pillar, arches and also used in the construction of the road. Okay, so those are the uses of the brick. We can use it for the construction of wall, pillar, arches or road. In that case, it subjects to compressive load and hence the compressive strength is an important property. So as discussed earlier, as discussed in the definition of compressive strength, the bricks are always subjected to compressive stresses or compressive load. So it is very important property of the brick. Okay, similarly other properties are also related to compressive strength of the brick. Okay, the bricks of good quality have high crushing strength, but the quality of the brick are varies considerably depending upon the availability of raw material and manufacturing process. So the good quality brick, it always have high crushing strength. Okay, the load required to crush the brick is more as compared to the lower quality brick. Okay, and it varies depending upon the availability of the raw material. Availability of raw material means the clay and the manufacturing process. Okay, so remember that the compressive strength of the brick, it depends upon the type of the clay and the burning of the brick. Okay, and also the manufacturing process. Next, compressive strength of the brick is the resistance to the crushing under gradually applied load. Okay, so as discussed earlier, it's a resistance of that particular brick to the crushing under the gradually applied load. The bricks which are porous or underburned and contain excess calcium carbonate are weak in strength as compared to dense well burnt clay brick. Okay, the strength of the brick in wet condition is less than that in the dry condition. Therefore, the test is carried out on brick kept in water for soaking for 4 days. After filling a frog with the cement mortar, 1:3 ratio we have to use, as the strength of the mortar after 3 days is approximately equal to that of the brick. Okay, now we will discuss the procedure which has to be followed for conducting the test. First of all, we have to select any 5 brick from a pile. Okay, we have to select any 5 brick from a pile. Then we have to grinding the two bed faces to provide the smooth, even and parallel face. We have to grind, or we have to make the surfaces faces even and smooth. Okay, after that, immerse the brick in water at a room temperature for 24 hours. So after making the faces even and smooth, we have to immerse all those 5 brick in a water at a room temperature for 24 hours. Okay, after 24 hours, remove the specimen from water and drain out any surplus water. If any surplus water is there, then we have to wipe it. Okay, and then we have to fill that particular frog. Prepare the cement mortar with 1:3 ratio using the clean sand of grade 3 mm and down. After wiping out the surplus water, we have to prepare the cement mortar. Remember that it consists of cement and sand and water. Mortar, it is consist of cement, sand and water. Okay, and the ratio is 1:3. 1:3 means 1 part of the cement is equal to 3 part of the sand. Remember that we have to prepare the mortar of 1:3 ratio, which means that the 1 part of cement is equal to 3 part of the sand. Okay, and the size of the sand is 3 mm. The size of the sand is 3 mm or less than 3 mm. After preparing the mortar, we have to fill the frog and voids in the bed faces with the cement mortar. Okay, so all of you know that what is frog. Okay, and after preparing the cement mortar, we have to fill that particular frog and voids in the bed faces. After filling the frog, we have to store the bricks under damp jute bags for 24 hours. After filling the frog, we have to store that particular brick in a jute bag for 24 hours. Okay, and after that, again we have to immerse them in a clean water for the 3 days. After keeping it in jute bag for 24 hours, we have to place those bricks in water for 3 days. After 3 days, again remove the bricks and wipe out any traces of the moisture. Okay, and place the brick specimen in between plywood sheets with the mortar filled face facing upward on UTM, or we can consider UTM also, or compression testing machine also. Okay, so we have to place the brick specimen in between plywood sheet with the mortar filled face facing upward on UTM. After that, we have to apply the load axially at a uniform rate of 14 Newton per mm square per minute. The application of load should be uniform one, and that rate should be 14 Newton per mm square per minute. Okay, and that we have to apply till failure occur. After that, we have to note down the maximum load at failure. So after applying the load, the failure of the brick will take place and load down the load at which it fails. In this manner, test all the 5 specimens as above and find out the average compressive strength. Find out the average compressive strength. So which formula we have to use to find out the average compressive strength? It is given by the load at which the brick fails, okay, divided by the area of brick. Oh, okay, first area of the brick. Okay, now we will consider the observation. The type of the brick which we have used is the local burnt clay brick. The size of the brick is 220 mm by 100 mm by 100 mm. So while taking the brick for the compressive strength, you always measure the size of the brick, because depending upon that size, the compressive strength also varies, because it is force upon area. The size of the frog is 100 mm by 40 mm by 20 mm, and the date of testing is today's date 24/8/2020. Okay, this is the observation table. Okay, in that consists of first one is 5 serial numbers are given. The second column is identification mark S1, S2, S3, S4, S5. Okay, third column is surface area. Surface area means the area which is faced to compressive characteristic. Okay, so it is 220 mm by 100 mm. Surface area will be 220 mm by 100 mm. So it becomes 22,000 mm square. It becomes 22,000 mm square. So the surface area for all the brick will remain same. Okay, the only crushing strength will vary. So the crushing load is 80 into 10 raised to 3 Newton for the first brick, 16 to 10 raised to 3 Newton for the second brick, 15 to 10 raised to 3 Newton for the third, 86 into 10 raised to 3 for the fourth brick, and 74 into 10 raised to 3 Newton for the fifth brick. Okay, once you know the value of surface area and the crushing load, we can easily determine the crushing strength, and that can be given by Newton upon mm square. So first of all, we will take 80 into 10 raised to 3 divided by 22,000. It will give you the value of crushing strength 3.63. Okay, similarly, by using same formula, we have the crushing strength of the second brick 2.72. For third brick it is 2.27. For the fourth brick it is 3.90, and the 3.36 for the fifth brick. Okay, so this is the individual crushing strength of the brick, and if you consider the average of it, then it is 3.176. Okay, so this is the observation table. Now the results are, the average compressive strength of the given brick is 3.176 Newton per mm square. This is the average compressive strength which we have determined over here, 3.176. Okay, the lowest compressive strength of the brick is 2.27 Newton per mm square. The lowest compressive strength of the brick is 2.27 Newton per mm square. Okay, the requirement for the compressive strength is, this is the class of the brick, 350, 300, 250, 200 up to 35. Is it okay? Depending upon the compressive strength characteristic, this is the class of the brick. Okay, and in Newton per mm square or MPa, it will become 35 MPa, 30, 25. So going down to 3.5 MPa. Okay, those are the compressive strength of the brick, and those are the requirement. So as per IS 1077/1992, in no case the compressive strength of the brick should be less than 3.5 MPa. Remember, those are the requirement of the IS code. Okay, in no case the strength of the brick should follow below the 3.5 MPa. So this is the last class. In no case it should be less than 3.5 MPa. And the second requirement is the compressive strength of any individual brake shall not fall below the average compressive strength specified for the corresponding class of the brake more than 20%. So the compressive strength of any individual brake shall not fall below the average compressive strength, okay, and that must be not more than, that must be more than a 20%, okay. So the difference is 20%. So from the given data, from the given observation table, we have the average compressive strength 3.176, okay, and the requirement is as per IS 1077 1992. In no case the compressive strength of the brake should be less than 3.5 MPa, but we have the average compressive strength less than 3.5 MPa, that is 3.176. So the conclusion is that it does not satisfy the IS requirement, as the compressive strength, average compressive strength of the brake is less than 3.5 MPa. So it shows that it does not satisfy the IS requirement. So this is all about the compressive strength of the brake. We will stop here. Thank you.